Today, we're going to look at the Earth's surface a little differently. Not as just, solid ground, but as this incredible, dynamic battlefield. It's a place where these immense forces have been in a constant struggle, shaping our world for literally billions of years.
I mean, seriously, have you ever just stopped and looked at a giant mountain range or a massive canyon and thought, how in the world did that even happen? It's a pretty simple question, right? But the answer? Well, the answer is this sprawling epic of creation and destruction, a story that's written in stone. So, let's find out how these amazing landscapes really come to be.
Okay, so this right here, this is basically our roadmap. Every single landform you've ever laid eyes on is the result of what you could call a cosmic tug-of-war. It's a battle between two major teams of forces, one that builds the land up from inside the Earth and another that tears it all down from the outside.
To really understand this battle, we have to get to know the players. And it all comes down to something called geomorphic processes.
Now, geomorphic process is the big, official term for all of this. But really, just think of it as the rule book for how landscapes get made and, well, unmade. It covers the whole shebang, from the super slow creep of a continent to the powerful rush of a river. And all these processes are driven by two very different kinds of forces.
First up, let's meet Team 1, the endogenic forces. I absolutely love this nickname for them, the builders. Their entire job is to push, to lift, and to build up the Earth's surface. They're the ones creating the raw material for our planet's landscapes, things like massive mountains and entire continents.
And on the other side of that tug-of-war rope, we've got the exogenic forces, or as I like to call them, the sculptors. Their power comes from outside the Earth, and their mission is to break down, carry away, and reshape everything that the builders create. It's this constant tension, this push and pull, that gives us the incredible world we see around us.
So let's start with that first team, the builders. These are the powerful forces that construct our world from the inside out. And they don't just work in one way. They can be unbelievably patient, but they can also be incredibly violent and dramatic.
The builders have two main strategies. On one hand, you've got these super slow movements. The technical term is diastrophism. This is the patient work, the folding and faulting of the Earth's crust over millions of years to build up continents and mountain ranges. But then, you've got the other strategy, sudden, violent outbursts like earthquakes and volcanic eruptions that can completely change a landscape in just a matter of minutes.
And you might be wondering, what's fueling all this construction? Well, it's the massive heat engine churning deep inside our planet. We're talking about energy from the decay of radioactive elements, friction from the Earth's spin, and even leftover heat from when the planet was first formed. All of that powers these incredible land-building forces. All right, now let's hop over to the other side of the battlefield and meet the opposition. These are the relentless forces that work from the outside in, the sculptors.
So if the builders are running on the Earth's internal furnace, the sculptors get all their power from our ultimate external source, the sun. It's the sun that drives our weather, all the wind, rain, and ice, and those elements become the primary tools for carving and reshaping the land.
The sculptors work with this really methodical three-step process. First up is weathering, which is just breaking down solid rock into smaller, looser pieces. Then, gravity takes over, in a process called mass movement, just pulling all that loose stuff downhill. And finally, agents like water and wind get to work with erosion, picking up that material and carrying it off to dump it somewhere else.
Now, of all the sculpting tools out there, running water is probably the most powerful and the most persistent. It's like the master artist of the landscape. From a tiny little stream to a huge, mighty river, it is always at work, constantly carving, carrying, and shaping the land.
And a river is a true artist. As it flows, it chews away at the outer banks of curves and drops off sediment on the inner banks, creating these beautiful winding patterns we call meanders. Over a long time, a meander can get so loopy that the river just cuts it off entirely, forming what's called an oxbow lake. It's this living, breathing, moving system. But hey, water doesn't get to have all the fun. In really dry, arid places like deserts, where there isn't much vegetation to hold the soil down, wind becomes the star of the show. It becomes the dominant sculptor, basically using sand and dust as its personal sandpaper. And you want a perfect example of this? Check out the mushroom rock. It's so cool how this happens. The wind can't lift the heavier sand particles very high off the ground, so it just blasts away at the base of a rock formation. Meanwhile, the top gets eroded much more slowly, and you're left with this incredible, top-heavy shape.
So we've met the players, the builders and the sculptors. But how does this game actually play out over millions and millions of years? Well, geologists have come up with a couple of really interesting theories to explain how landscapes evolve over the long haul.
The two classic models come from two guys, William Morris Davis and Walter Penck. Now, Davis saw it as a predictable cycle, almost like a life story. He thought there was a quick period of uplift, and then erosion just slowly wears it all down through these clear, distinct stages. Penck, on the other hand, argued that no, uplift and erosion are happening at the exact same time in a constant struggle. For him, what really matters is the rate of that battle. Who's winning right now?
Take a look at Davis's model here. Just follow that curve from left to right. It kicks off with a youthful stage of really fast uplift, which creates those steep peaks and deep valleys you see on the left. As time goes on, it enters maturity, where the valleys get wider and the peaks get lower. And then finally, way over on the right, it reaches old age, where pretty much everything has been worn down to a nearly flat, featureless plain.
But Penck's model is less of a linear story and more of a real-time status report. For him, the shape of the slopes tells you exactly what's happening in the battle right now. If the rate of uplift is winning, you get these steep, convex slopes like you see on the left. But if erosion is winning, you get these gentler, concave slopes, like on the right. The landscape itself is a direct expression of that never-ending tug-of-war.
So, after looking at all of this, the forces, the processes, the theories, what's the one big idea you should really take away from it all?
Here's the most important point. The ground beneath your feet is alive. It's not static. The hills, the valleys, the mountains, and the plains we see, they aren't permanent fixtures. They're just temporary forms in a huge geological story of creation and destruction that has been unfolding for eons and will keep going long after we're gone.
So, let's just boil it all down. Our world is shaped by this constant battle between the internal builders and the external sculptors. This whole process, happening over almost unimaginable amounts of time, has created every single landscape we see. And that view out your window right now, it's just one frame, a single fleeting moment in this planet's incredibly long movie.
And that leaves us with one last thing to think about. When you look at the world around you, knowing what you know now about this constant push and pull, what chapter of this massive geological story do you think we're living in right now?